So I'm excited to present my talk. It's titled Think Micro, Why Modular ML Pipelines Are Better. My name is Thierry. I'm a proud member of the MLOps community in Montreal. And so I'm excited to spark the conversation, share ideas, and continue the discussion afterwards. So the agenda for today, I'll introduce myself first, and then I'll talk about the 0 to 1. How do you answer business questions with data? And then the 1 to 100. You have data, you have insights. How do you deploy that and you make it a lasting impact on the company? At the end of the talk, I'll take a step back and discuss the concepts and the ideas behind building a modular stack. This is where maybe I'll have spicier takes, so be on the lookout. Okay, so who am I? I've been a user of Hamilton, an open source library that I'll be sharing with you today since 2021. It's been a while. I started contributing to it in 2022, and now since June of last year, I'm also employed by the core maintainers. So I'm mainly biased by my enthusiasm for the tool. I think it's a great tool, and I work to make it better every day. I actually started using Hamilton while doing my master's at University of Montreal. So I was a health and ML researcher, and I work in a lab in psychiatry using smartphone data for mental health research. I also did an internship at Move AI, which is a Montreal startup / small consulting business. It was a great work environment, had great colleagues. And I had the opportunity to teach data science and ML as an instructor assistant for live cohorts of courses online. I taught NLP and LLMs, causal inference, and search engines. So if you're interested in that, feel free to come chat with me afterwards. All right, so the first part of the talk, 0 to 1, solving data problems. Just by show of hands, how many people here would consider themselves data analysts or data scientists, they write code to solve business problems on the day-to-day? Cool, that's a good percent of the crowd. Other people, I'm sure it's going to provide value to you too, because you're probably in the periphery of it, and it's good to have an understanding of this. It usually starts like this. You have a Slack notification. You have Caroline, your product manager, that's asking you how are the sales from last quarter looking? This is a simple question at first sight. You open maybe a Jupyter notebook, a Python script. The specifics of the code aren't that important, but you see, you load a data file, rename a few columns, maybe change the type, extract the month from the timestamp, convert the currency, do a group by and aggregation, and you're good to go. This took you maybe 30 minutes. You had a question, you loaded data, you had insights, you send back to Caroline maybe a table, a plot. She's happy, right? But the question leads to another. So did we improve over the previous quarter? A question in business always leads to another. So you add a few more lines of code, you append, you load a new data file, you copy paste some transform to make sure you again convert the currency rates. You do the same aggregation again. You have your answer. And then you have another question. What seems to be the key drivers? This one's a bit more open-ended, right? You need to come up with some ideas, scramble into the data, and try to look for satisfying answers. Did our new chatbot improve user retention? I'm sure some of you are currently dealing with that. Not simple. This takes time. You need to find the right data, ask the right questions, and it's a very iterative process. And also, at some point, Caroline pings you and she said, did you remember to remove client X and client Z from the analysis? We have this particular deal with them. And so, well, obviously, she didn't tell you beforehand, right? So you need to go back to your script, your long lines of code, and add conditional statements. Make sure to exclude client X, client Z, rerun the analysis, send the new data results to Caroline, and should be good. If you're doing ML or LLMs, it's most likely the same. Brandon, your senior MLE, is asking you, did you think about trying feature set number 3? Or did you conduct hyperparameter tuning? What about comparing logistic regression, neural networks, gradient boosting? And now Brandon's probably looking at LinkedIn and hearing about all these cool prompting techniques. And so he's what about this one? It might solve our problem finally. Or what about fine-tuning LLMs? I'm poking fun, but that's the nature of the job, right? You have asks that are significant to the business or your users, and you need to investigate and find relevant answers and answers that are fulfilling to your users or your business partners within the organization. There's a sort of data science routine. And data science is, I believe, the correct terminology. You're doing science with data. You form an hypothesis. It starts from the business question, the many ones I shared with you already. And you have to find some data. This is not always trivial. Like you might have issues like getting the credentials to access the production database. Maybe you have a data warehouse, ingest some data. This can be very painful. I know we have also data engineers in the crowd, like have fun here getting me the data. Then I implement code for my analysis. This can take some time, but usually it's not that bad once you have the data and you kind of know where you're going. You run the analysis, and there will be bugs, right? You fix the bugs. This is very high variance step. It can be a lot of time, maybe not. And finally, when it works, when you run the analysis from top to bottom, you have some results to explore and share back. And then you do that a bunch of times. What I want to make sure that like we're all agreeing upon, like that's the nature of the job. This won't change. All we can do is make it easy on ourselves, make that more efficient, and make it a better experience for everyone within the company. Also, as I showed you before, like we have a bunch of questions that keep like stacking and we're appending code and we have a long script. And what happens eventually is that each bug that arises or each new question that is asked is increasingly costly for you to solve. Like it will take you more time to execute the code, more time to figure out the bugs. Eventually, there will be also like duplicated statements. It becomes hard to read and actually remove or add the things you want to. And so we should dream for something better. We keep appending code to our analysis, and it starts to look like this, right? You have data, and the boot kicks the bowling ball that makes the bowling pin fall, and hopefully there's money at the end of the tunnel. I have to warn you that like as a data scientist, or even like as a data science team, this is also very scary for you, because if you can't show value to the company in your efforts, like your job might be at risk, or like we see the market stuff right now. And also, they might start to question like, you're fixing bugs all the time, but you wrote that code, right? And so writing good code is good for everyone involved. There's a trade-off, right? That seems to appear from what I've discussed so far. It's like move fast or build to last. For those, I like to sit in the back and I don't wear glasses, so it's always an issue. So on the y-axis, for those who can't see, it's move fast. Towards the top, it's faster. And on the x-axis, it's build to last. And we have like number one at the top, just ship the notebook. Like it will be a mess, but hopefully like this run on the other person's machine. And like they will get the answer and we can like just store the notebook somewhere. Hopefully it keeps running in the next month. You can structure code into modules and config. So now we're like moving along the curve and we're spending a bit more time building something that's more robust. You can change config, you can add code to it, and it's like it still works. It helps you like answer additional business questions in a decent cadence. And then number three is like, oh, take your time, build something that's very robust, but like it may take more time to answer Brandon or Caroline for the present, like the very urgent questions that they have for you. The thing that I want to highlight is like we're most likely everyone is like somewhere around the curve where they prefer to be. Maybe like more engineer folks like to be towards the bottom right, and they like to build cool system, but it's not always the best solution. But if you're like you try to move fast all the time and answer every question that you receive on Slack, it will bite you in the end. Unfortunately, even if you write messy code, ship the Jupyter notebook, Caroline and the team love it. Like the team love the report. Can you refresh it weekly? And now you start to have a new problem. We have operational concerns. It was cool to have like this code on your machine. It worked. You had the answer. You could like message back Caroline, but now you have to figure out how to read write directly from storage. This might be like a database, a file system storage in the cloud. You have to do data quality check, because now like it was easy for you to check like the full CSV, the full Parquet file with your data and make sure that it made sense. But when you will be reading directly from storage, you have to ensure that that the data is proper. start using version control. I hope you've been using Git so far along like your journey in Jupyter Notebooks, Python scripts and all, but you should start as soon as possible. It will save you a bunch of trouble. If you're lucky, you have continuous integration. Like this will check your code, make sure you break nothing. If you're very lucky, you have engineers to end off your project. This is controversial, but like we love you, data engineers in the room. But also it's bittersweet because usually what it leads to is a lose-lose because you didn't write proper code and it will probably be trashed and they will need to write it from scratch. Maybe you're using Python pandas for data transform, and the size of the data in prod is so much bigger, they need Spark, for example. And so all of these things, if you provide a report that's valuable and they love it, it will require you to go through this eventually. And so you should start thinking about this from the start of your project. You shouldn't build these things day one because you wouldn't be moving fast enough. But some of the things you do, some of the questions you're asked will be recurrent and will need this in the future. So we should plan ahead. Otherwise, like your weekend will look like this. You sent your answers on Friday, Caroline loved the report, and now you're like, oh, goddamn, I need to make sure my Jupyter notebook is like well-structured code with documentation, with checks, tests maybe, and send it for the team to put in prod. We would like to avoid that, right? This was a 0 to 1. We were able to get the data, answer the business question. We delivered value. Like we did answer the question, we did deliver value for the business. But this is where like the most challenges the teams face in data science are. It's like going from something that worked, something that provided value once, to something that's consistent over time and that's reliable. It's like building train tracks and having a train system that's much more consistent than cars and traffic. And this is the main takeaway of the presentation. Tools allow you to modify these trade-offs. Like if you have a good tool, a good system around you, it allows you to build both. It allows you to build faster and more reliably. Like this is very important to consider because if you're doing things one-off all the time, you're like, there's a ceiling to how productive you can be. If you have good tools, this should help you along the way. But also one thing to be aware of is like bad tools slow you down and make things more brittle. That means that like it might be slower to do things the first time, and it only gets slower as you have more projects. This is not to say that like testing is bad. Obviously, testing is useful and it's good. But if you're testing every one-off question, adding data validation to every one-off questions, you're missing the point. Data checks and tests are required for systems that will be repeated over time and that will need to be reliable. Not all business inquiries need this level of scrutiny. And maybe people that like the modern data stack are familiar with that. Like we have the same picture, but at the stack level, like you have HubSpot and now you're kicking an Airflow job and you're sending your data from Airbyte to Snowflake, running dbt, SageMaker, logging your model into weights and biases, more Airflow. This, like, if it sounded like gibberish to you, it sounds like gibberish to most people. So you should try to avoid that too. If you have too many, like, none of these tools are bad in and of itself. Like, they do solve business problems, but having many tools doesn't make you more effective per se. So this is now when I introduce Hamilton. I will show like how I've been using it, how it's been useful to me, and it starts from a very basic principle. It uses like regular Python functions. There are no imports or anything. It's just Python code. And what it does is like, this is the ABC of Hamilton. There's function A, function B, function C. They have type annotation. So like A returns an int, an integer, B returns a float, and C returns a float also. And via their parameter name, so like A depends on external input, B depends on A, and C depends on both A and B. We have a very clear sense of the dependencies between the different transformations we might have. And it allows us to reconstruct this graph, right? And this is like highly visual. It's useful to get a sense of a complex system. Like, okay, this is how my data flows through my transformation. Nothing too crazy so far. I'm on schedule, great. So what is Hamilton? It was built initially at Stitch Fix, which is a company that works in clothing. They needed to build a feature engineering platform for their forecast team. They realized that like forecast was very important for their business, and they were copy pasting a bunch of code, pandas code to create features, and so they needed a more principled system for creating like hundreds of columns in a data frame. It was open source in 2021, and it became a much more flexible system that supports like any Python type, not just feature engineering for machine learning or creating tables. And it can power like your ETL, your ML training workflows, or even like your LLM-based application nowadays. At the core of Hamilton, there are like two things to be aware of. It separates data flow definition, which I just shared with you. It's just writing Python code, writing your data transformation. This is mostly what like data scientists or data analysts might do. They write code to like investigate the sales of the company, or maybe they write a data transformation for a machine learning model to predict churn for customers. And it separates the data flow definition from the data flow execution. So data flow execution is when you actually run the code. And this is like a very important separation, because when you write the code, you shouldn't be bothered by all of these like production things along the curve that we discussed, like data quality checks, caching, backfilling, like things that data engineers care about. Like the data scientists, like honestly, shouldn't have to care about this day one, but they should have a clear path to add these features to their projects. And so data flow execution is where you productionize your solution with Hamilton. It might be done by someone else, and that's also like a strength of Hamilton. Like it defines like a clear end-off between members of the same team. But when it was designed, Hamilton at Stitch Fix, they had a very like self-serve culture, and so like data scientists were also able to go from step 0 to 100 by themselves. So this is what like the code I showed you before. Like this is a new question. Like here we have data that looks into the company information, and also looks at the employee growth over time for different companies. And we see a bunch of things that are like code smells. Code smells mean like code that could be written better, that code that practices that would improve your code. We have like a hard-coded path to a file. We have a bunch of steps that are bundled together, and it's unclear like what is actually happening in the code. If you're not going to read through all of them, you won't know what it does. And also, you won't know why it's done a certain way, because there's no like code. There might be like some code, some comments in the code, but that's not an easy way to navigate. And there's no documentation. There are hard-coded values. Like if somebody was to inherit that, it will probably take some decent time to do anything meaningful with it. So what you should do is, again, I showed you the way to define functions with Hamilton. Like this, now it got a bit small, but like the gist of it is like we're defining functions. And like function at the top is like loading the data. The second function is company info. And we have a docstring that says select the columns containing general company info. And then we have another function that's like number of companies by funding stage. And now we have a very clear sense of each step to our analysis. And we also have explicit dependencies between them. So if I was someone that was just onboarded on the team, I could just look at this picture and have a very clear sense of what's going on. Like this came for free, right? This is directly derived from the code. You just like display all functions, and it will output that for you. You can keep that in your documentation. You can produce it in your notebook as you develop, and you have a clear sense of what your system is doing. This only gets more valuable as you add more functions, right? When I went through like the data science routine, it's not that difficult to answer the first question, but when you have like tens of questions that are common, like how is employee growth? How is like stock growth? How are sales going? How are sales going by region? Like all these questions will come back. And so if you have a sort of library or catalog of all these transforms, it's easy to assemble them and create this graph. And also like just as a user, I'm sure like anybody would prefer to inherit that instead of that, right? Like there's literally not much or almost nothing you can do if you get this file. Somebody sends you this file, you saw this on GitHub, like this is not useful to anyone. Here at least there are some parameters, there are a sense of things you can change. And like in the graph, you see clearly like the input is the raw data path. And so if you add another data file, for example, simply change that data path and you could do the same analysis again. To answer new questions, simply add more functions. like this is an approximative like match between the two, but like on the top half of the right side, you have the same functions on the left, and we added a few more functions to look at stock growth and how it relates to employee growth over time. So you get a sense of how it makes it easy, and you keep the same pace while answering new data science questions. Hamilton helps you write better code. Just like if you notice, like there's no Hamilton import, there's nothing, right? I just shared with you a way to write Python functions. Like you don't even need to pip install anything. This is just regular Python. But Hamilton also helps you write better code. Once you start using it, you will realize that like writing one code per transform can become tedious. And there are some function modifiers, so ways to reduce code duplication. I have some extra slides at the end if you're curious. There's a Hamilton UI that's like a Docker container that you can self-host, and that will allow you to just have a catalog of all this code in a centralized way. And so it's easy for your team to like look at this catalog of transform and have a sense of what's available. So like if a team is developing features for forecasting, maybe it's also useful in your own work, and this could be a centralized way to find this code. We have a Jupyter Notebook integration that makes it easy for people that like to use Notebook to write new functions. It's like very iterative, like the visualization will update as you add code and you can quickly execute it. We also have a CLI tool, like a command line tool that allows you to diff data flows. So if you have a version of the code and you have another version of the same code, you can see in this sort of visualization of the nodes that were added or the nodes that were changed, the nodes that were deleted. And also we have pre-commit hooks. So you can make sure in an automated way in your CI, for example, that your code is valid and it produces a valid data flow. And we're working on IDE completion and code navigation for people that like VS Code. And if you're not using VS Code, we're building like a language server. So if you're savvy enough, you could plug it into another IDE. So far I just talked about writing code, but we're still like reshaping the curve, right? Code that is readable, as I showed, like you can make sense of what it does. You have doc strings, you have type annotations. It's maintainable. It's easy to add new functions. It's easy to delete functions. It's easy to, if you are a junior that like needs to contribute on day one, Hamilton makes it easy. You just edit a single function, add a function or two, and this principled approach makes it easy. And it's also reusable, as I said, like if you're working across projects, there are things that you can import directly and reuse. This facilitates both the 0 to 1, as I said, because it makes the iteration cycle tighter, and the 1 to 100, because as I will show you, it makes then adding tests, data validation, and all of the good things easy. So execution. Let's say I have this function-based code that I shared with you. It's the same code as before. This is an imperative way of writing code. Like, don't be scared by the term, but the idea is just like you're telling the machine what to do step by step. You're saying, load the data, apply the function company info, apply the function companies by funding state. And you tell your script to do it one by one. But this gets very complicated when you have a bunch of functions. And if you're adding or removing functions, you have to edit that each time. If you're using Airflow, you might be familiar with that. Like if you have DAGs that aren't a simple line of operation, it can get messy and very painful to deal with. But Hamilton has something better to provide. So I close the screen. Great. Okay. So Hamilton is actually a declarative framework. What you do instead of telling the machine step by step is you request nodes to be computed. So here we have a builder on the first line that passes a module that contains our analysis. This would be like this file, like this would be my analysis. I import it and pass it to the builder. Build the builder, and you get a driver, the variable dr. And with the driver, on the bottom of the picture, you see that you can just give a string, that's the name of the function I want to get. And you pass it the inputs of the path where your data is. And you get the results. It's a simple dictionary that will contain whatever employee count by month df is. Must be a data frame. It's very simple, but it saves you a lot of headaches because maintaining that is also painful. So if you are to write a cool like library of transform, and then you tell your data engineer, hey, make that work, might not be trivial. And again, it's a lot of back and forth and figuring things out. Whereas this takes care of it for you. Like it builds the graph, it figures out the functions it needs to execute. It won't execute the full graph. It will only execute the path that's required. So should have added an image, but like if here I'm to ask, was employee something count DF by month? Like that's this variable on the right. So it will only execute the 2 or 3 nodes that are required. So this allows things like that. That's the code I use for my master's. It's only a small chunk of it. It looks painful, but actually it's great. Why? Because I don't need to add all these nodes together and point them. I just have a Python module with functions. And all of these blocks are not things you build on day one. Like this is to train a machine learning model, make sure my split is not having any leakage. I'm then storing the trained models, storing the evaluation, doing some bootstrapping, doing some statistics over like the results for evaluation and benchmarking. But each time I was going back to my code and I needed to, what about trying this new metric? What about trying new hyperparameters? It was only about writing a function or two, hitting enter and running my code again. So now I have like a bunch of slides. I will go a bit fast over them just to tell you that those are things Hamilton can do, and we can come back to it if you want to afterwards. This is the code I wrote, and this is what I needed to execute it. Like it's what 21 lines of code. I have my builder. I pass it the tabular module and the model evaluation module. So I can pass it any number of modules like Python files, and it will assemble this crazy graph all by itself. Then I pass it a config. So this allows me to add or remove nodes on the fly from the graph. And then I have some input. So like, where is the data? What's the offset? What's the label? How many trials of hyperparameter tuning and how many folds of cross-validation? And I just ask it, give me the best model and give me the performance metrics. And it executes all of that. It figures it out in like 2 to 5 minutes. I have my model and my statistics in my file system. So those are all the things that, like, those are a few things Hamilton can do, but those are the slides I built for today. So you have data quality checks that are easy to add. You simply add the check by function. So it's like you add the decorator and it's done. You have configurable in and outs. This is great for data engineers and end-off model because your data scientists can write code the way they want. And when they go to prod, your data engineer can simply change where the data is loaded or saved to. So that can save a lot of time, especially for enterprise settings. The Hamilton UI that I mentioned previously also like brings catalog, lineage, and observability over the run. So it's a few lines of code and you will track everything that's run. Since you're writing functions now, it's very easy to unit test. So you can check transformations one by one if they're critical, but also do integration tests. Integration is like a very easy and flaky word, but like if you add a data flow, and it's very important for you to be able to say, give data and give me like financial predictions for next year, you can make sure that this path of the data flow is tested and works all the time. You just write a test that says, get me this value, and you can do checks against it. While like other parts of the data flow might be more brittle or less important, but this one you have to make sure like it works as you expect. We have ways to just execute it on Spark, Ray, or Dask. So this is like very free and like easy to achieve. I think that's very cool. We had like an open source contributor that like he came in, wrote a few lines of code, said, hey, I want this to run on Dask, specify how many GPUs, how many CPUs per machine. We helped him a bit, he figured it out himself, and now we have cooler support for it. And also, like I'll be saying it again in the presentation, but Hamilton has a very open system for like plugins, and so it's very easy to tailor it to your needs. And you can run it within any orchestrator or serverless infra. I'll go a bit faster with this. So data quality check, it's like you add the decorator, say the data type, the values that are allowed. The configurable IO is like, now I added the please read from Parquet, save the XGBoost model to JSON, created 2 new nodes. Like this, the data scientist didn't write these nodes. Like it may be the data engineer that wants to execute code. The Hamilton UI is you add this. You said project ID, username, my email. Don't spam me, please. DAG name, and like you add a tracker. Like it's literally all you have to do, and everything's logged. I have a pet peeve with like experiment trackers. Like I have to write MLflow log everywhere in my code, and it sucks. MLflow is great, but like adding this to your code is like making PRs to add log, and then the variable name changed, and it's a mess. Here it's like at the node level, because each node you define is an asset you care about, and so you don't have to micromanage another framework. So this is like what the UI looks like. It's cluttered a bit, but like you see there, you have the nodes, the graph. Like we have a complex graph at the top. You can inspect the previous runs. This is a waterfall chart of the execution time. You can inspect results. How to run it within an orchestrator? It's simple. Like here we have Airflow. We define a step that says prepare data. We import Hamilton. Hamilton is just a library. You can run anywhere. I used it within a Streamlit app. I use it within a Fast API app. I use it like via the CLI. Like it can run anywhere. And so you just import it within your Airflow task. Because Airflow, they incentivizes you to write small modular chunk because it's a pain to manage. And so you can write complex things in Hamilton. This is a single step that makes sense. Pre-process data, and you import Hamilton, execute code. Second step is train model. Again, very simple. So your Airflow like DAG is also much easier to manage. You have two steps and it won't go crazy. Those are the artifacts you care at this level. It's train model and pre-process the data for the model. But at the micro level, when you're writing code, it becomes like very granular and easy to manage. This is like the fear mongering I needed to add towards the end. So like McKinsey reports that 45% of projects go over budget, 7% over time, 65% provide less value than predicted, and 17 are like an issue that threaten the existence of a company. I hope we don't fall in like these cases. I think Hamilton is a good way to build a platform. You shouldn't jump from 1 to 50. You should try to go 1 to 2, 2 to 3, and like adopts the features you need. Because I think that's the thing that's scary for a data team. It's like, we have no lineage. We have no clue who changed the code and how it affected the data. And like, you have to opt in an entire platform, an entire tool. It's going to cost a lot of money. You have to train your team to use it, but it shouldn't be that way. You should adopt the relevant features as the requirements evolve, and for the parts of the code that require these changes. So I'll go quickly over that. Build a modular stack. Don't build a modern data stack. I think like this is something that people should have in mind. Like there's data, there's execution, which is like the thing that executes code. There are expression. This is a library to write data transform. I could have added like libraries for natural language, like maybe Hugging Face, unstructured, Llama index. At the logical, this is where Hamilton live. And it's like very similar to DBT. If you use DBT, DBT is only for tables and SQL, but Hamilton does the entire spectrum of Python types. And like LangChain would be a similar type of product, but only for language related applications. Now, at the top of it, you have orchestration. And I believe a lot of teams over optimize for orchestration. They write code that will please the orchestration framework, but orchestration in and of itself doesn't solve any business problem. And so you should really start like at the bottom with like expression and logical levels, and make sure that your code runs, it runs on the data you need to, and it provides the insight you need. So this is like maybe the last slide I'll leave, and it's a comparison of like similar tools to Hamilton, and I'm ready to take questions. Thank you. Yes. Should I pass? I guess if you're comfortable just raising your voice. Yeah. Please go ahead.
One question. Is there a possibility to display like some values on the nodes? You know, first diagram you have to present.
Yeah. So
debugging and parameters and return just by open config.
Yeah. So we have like here. Sorry. No, I wanted to go here. We have a bunch of adapters. You see the build as like with adapters, and it can have many things. There are some adapters that allow you to just print the values as it's executed, but the Hamilton UI will allow you to log that and inspect that. But this type of visualization it's like you can customize it, but like it's mostly there for understanding the code. But if you want to inspect the value, like the Hamilton UI it provides that feature. It's free, it's open source. Everything I presented is free and open source. So like I think Hamilton's great. It's free and it's very extensible. We have a very responsive community when you have questions or like to add features. Yep. 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 There's no like framework specific code there.
I like it. However, does that mean that if I jump back to like the big,
yeah, I'll try to find one. Can I take this, for example? It's a bit bigger for people that are far beyond.
Yeah. Sure. So does that mean that if I, for instance, want to use B, then I have to like change how the structure of that function actually works in order to rework it and use it much earlier and say a separate pipeline?
Yeah. So basically, so the question was like, what if I want to do the exact same thing that B does, but it might depend on other things? Yeah. So, like we have the only convention you have to learn for Hamilton is that. So how this is written. If you prefix functions with an underscore, it won't be read as a node. So you could have an underscore function that's like my complex transform, and B calls that complex transform, and you can import that underscore my complex transform in another project, and like you could change what's upstream of it. Does that make sense? So you can wrap it. Yep. So some people prefer to use that. They don't write a lot of logic in the Hamilton nodes, but then they use that a bit like an orchestrator, and they put like complex like series of steps within one function.
I think that's what I worry about.
Yeah, I think like as opposed to other frameworks that do orchestration, a very powerful thing is function modifiers that I have at the end. So you have things like extract columns, so we can get like individual columns from your data frame, or like parameterize on the right. Like it's a bit verbose, but with Hamilton, we're not afraid of having verbose code because it's clearer for people that read it. Like we read code more often than we write it, and so here in parameterize, for example, is the same function, but I give it like different dependencies. I say it's essentially a group by, but I say do a group by for on this column on age, do a group by on country, and it produces like with one function 3 nodes in my graph. We have a bunch of those. Like config allows you to switch which nodes is applied. So we have like a binary model versus a regression model, and just at the driver level, you can say use the binary model instead of the regression. And we have many of those, and they can help you write less code and get more nodes. That's it. Yep, please.
Yep. Let's say that I'm tinkering in one of the nodes. How fast can my iteration speed be? In the sense, is there a way to cache the responses of the dependent nodes?
Yeah, so we have an adapter for that too. We have different implementations with standard libPython and other third-party libraries, but essentially, it's something I developed that I think is very cool and useful. But let's say here, like we have an LLM on the left. It's like we have a client, a joke prompt, a message, a response from the LLM, and we can memorize the function based on the code version and the data input. So if the data input and the code doesn't change, and it run again, it will just load from cache. And especially when you're working with LLM, it's very efficient because you're saving API credits, right? If you have the same prompt and the same thing, like you're debugging other stuff, but you make sure that you don't send a bunch of requests to OpenAI. My pleasure. Any more questions? I think we're right on time. I'm proud.
Well, let's round of applause then.
Oh. Thank you.
Thank you so much, Steve. That was awesome. All right. So with that, we are at the end of the first half of our meetup. We now have access to amazing pizza, and we'll be back in about 15 minutes for the second presentation. Thank you so much.